Okay, welcome back once again sa ato ang class. This is a continuation of the previous discussion sa previous video. So we are now on dealing with multiple charges. So what if there are several charges present in a certain vicinity or area, and we are asked to find what is the resultant force or total force that is acted upon by a single particle or a single charge because of the presence of the other charges. So we can actually calculate for the force on, let's say there are four charges. So we can calculate for the charge that is acted on charge 1 because of the presence of the other three, and I'd calculate the separately the charge acted on this charge 2 because of the presence of these other three, charge 1, 3, and charge 4, and so on. So we can calculate the individual charge, the individual force acted upon on this separate charge or each charge by because of the presence of the other charges. Okay, so then we'll of course remember that we should treat the forces as vectors. So no matter ang direction asa siya. So it's like this. Say as what I said kanina, if we have four charges, then the resultant force on one of these equals the vector sum, or you just add the individual forces, the contribution of each, the forces that is contributed by each charged particle. Okay, so for example, if you want to calculate the forces that is exerted onto charge 1, so that is equal to the forces that is exerted upon by charge 2, charge 2 on charge 1, plus the force exerted onto the force exerted by charge 3 onto charge 1, plus the force exerted by charge 4 onto charge 1. So all in all, you have the F sub 1. So that's the total force that is acted onto the charge 1 because of the presence of charges 2, 3, and 4. So let's have an example. Ako nag-andaan dire. This one. So let's take a look at this. Let's have this example. So in this figure, we can see nga naatay tulo ka charges that is lying on the x-axis. Okay, so you have 2-point charges are located on the positive x charges in the coordinate system. So you have charge q1. So this is charge q1. So this is charge q1. That is 1 nanocoulomb. Okay, nanocoulomb, nano na siya bits. That's times 10 to the negative 9. Okay, and that is placed 2 cm from the origin. Okay, so nano siya dito na. Okay, 2 cm from the origin. And then we have q2. This one, this is q2 of charge negative 3 nanocoulomb, and it is placed 4 cm, 4 centimeter away from the origin. Okay. Now the question dayon is, what is the total force exerted by these two charges, Q1 and Q2, on charge Q3? So naay ma-feel nga overall force ang kaning charge Q3 which is placed at the origin. Okay, nasa origin na siya. So unsa ka ayang ma-feel nga force, total charge, total force exerted because of these two charges, Q1 and Q2. Okay, Q3 is ang ihang magnitude sa ihang charge is 5 nanocoulomb. Okay, so what are we going to do is, of course, ang tong formula is we are asked to find the total force exerted by these two charges on charge Q3. So you have F3. So this is vector. So una arrow na siya diha. That signifies that it's a vector quantity. So we have F, yeah, sorry. So we have 1, 3. So this is the force, that is the force exerted by charge 1 to Q3. Okay? Muna siya ang pasabot ana. Then we have the force exerted by charge 2 on Q3. Okay. So let's calculate first F1 on 3, or that's F1, 3. Okay. So let's calculate that first. So the force of the force of, so ang 1 ug 3, that's puros man na siya positive, di ba? Charge Q1 is positive, charge Q3 is positive, so it must be a repulsive. Yeah. So the magnitude of repulsion, the magnitude of force, ang repulsive force in duha is given by this formula. Just use the Coulomb's law or equation. We have K, that's the absolute value of Q1, and then Q3 over uh, R square. Okay. Or we know from from our previous discussion before, na naman tayo mga natay uh, value ani, di ba, unsa ng K, right? So we have K is, yun na siya i-recall sa atong previous discussion, na siya value 9 times 10 to the positive 9. And ang unit niya is Newton meter square C square. Okay. And then the charge Q1 is 1 nanocoulomb, or that's 1.0 times 10 to the negative 9. Okay. Times 10 to the negative 9 coulomb times the charge Q3, which is 5 times 10 to the negative 9 coulomb. And then R square, so the distance between them, that should be in meters. So that's 2 cm between Q1 and Q3. So 2 cm is 0.02 meter. So that is square. Okay. So if imuha na siyang i-multiply using, of course, a calculator, the result would be 1.12 times 10 to the negative 4. Ang unit is, of course, Newton, because this is force. Okay. Or this is just equal to negative 4 man na siya. So pwede na siya i-move og 2 places. From 1.12 mahimo siyang 112. So at ang point mo siya i-move sa ikaduha. Say it becomes 112 times 10 to the negative 6 microcoulomb. Right? Mao na siya ang rule sa atong scientific notation. So, unsa kay direction ani niya? So as you can see sa ato ang, you have Q1 and Q3, and they are both this is Q3 and this is Q1, so both positive man siya. So ang force nga ma-feel sa Q3 because of Q1, it's paana siya, right? Okay, repulsion man siya. Okay, ang direction sa electric field sa positive charge is ana man siya, right? Always radially outward. Okay. So the force nga ma-feel sa positive sa charge Q3 because of charge Q1, and they are both positive, is kani siya nga arrow. Okay. So and since ang direction niya is padulong dito sa negative x-axis, so this must be negative 112. Okay, micro coulomb, or that's 1.12 times 10 to the negative 4. Uh, okay, sa'yo. Okay, annotation. So this is 100, negative 112 times 10 to the negative 6. This is Newton, or just 112, it's negative 112 micro Newton. Okay. Micro stands for times 10 to the negative 6. Next is we have F on 2, 3. So force, force exerted by charge Q2 on charge 3, Q3. So we have K, Q2, Q3 over R square. So that's the same constant times 10 to the 9 Newton meter square C square. So charge Q2 is negative 3 times 10 to the negative 9. Okay. Negative 3 times 10 to the negative 9 coulomb. That's charge Q2, and then charge Q3 is 5.0 times 10 to the negative 9 coulomb. And then this is 0.04 square. Okay. So if you will calculate that using a calculator, so you will find that the result is 8.4 times 10 to the negative 5 Newton, or that is equivalent to 84 times 10 to the negative 6 Newton, or that's 84 micro Newton. Now the sign is, so this is absolute value manusia. This is absolute value. Okay. Now ang sign sa the force, ang direction niya is asa man padong, right? So i-drawing. So if you have, this is Q3 and this is negative na siya. This is Q2. So unsa man feeling of force sa Q3 because of Q1, since opposite man nilang sign, so ang Q3 is ma-attracted siya dito. So maka-feel siya force na, okay? And that's positive. Okay? Dito man siya directed sa positive x direction. So this is positive. So F13 is negative 112 micronewton, and F23 is positive 84 micronewton. So going back sa formula, the total force DI is just the sum of the individual contribution, di ba? Force. So we have F3, sorry, F3 equals, so ang F13, that's negative 112 micronewton plus 84 micronewton. So kung imo siyang i-calculate, that becomes negative 28 micronewton. So the implication is the final result is negative, right? Negative 28 micronewton. So ang ihang net force is going to the left. Okay? Mas dako gyud impact or contribution ang kaning Q1 because it's closer, right? So that's the overall force nga ma-feel sa Q3. So you can also calculate for the force that nga ma-feel sa Q1 with respect to Q3 and Q2. The same thing po, makalculate nimo ang force nga ma-feel sa Q2 because of the presence of Q1 and Q3. And I will leave that to you as and what do you call this? I will leave that to you as an exercise. So you can do that at home for practice. Okay, so let's move to another example. So how about this kini siya nga example? So medyo complicated na siya, but doable gihapon. Solvable. Okay. So in this case, medyo ano na siya, kay dili naman straight line unlike kaganina nga naa sila sa x-axis na. This time is 2D. So let's read the problem first. So from the figure on the right, from the figure on the right, na ay tulo ka charges that is set up in triangular fashion. So triangular ang iyang pag-set up. And then determine the total force. So with magnitude and direction that is exerted on charge Q. So where is charge Q? I will label it. So dara ang charge Q. Yeah. Labeled in red, muna siya ang charge Q. And then charge Q1, of course, nasa taas na ano siya? This is charge Q1, then this is charge Q2. Okay. So ang charge Q1 is separated siya og distance 0.5 ng diagonal niya nga. So directly kuan gid siya ang pag-link niya is on the straight line gihapon. So diagonal ang iyang arrangement kay triangular man siya nga setup. The same put sa charge Q2 0.5. Okay? So charge Q1 and charge Q2 they bear the same charge magnitude, that's 2 microcoulomb. And symmetric siya kay separated ang Q1 and Q2 actually the same, almost similar sila, symmetric sila except lang sa direction sa y because sa y-axis negative ang usa isa positive. But sa x-axis they're both the same, na sila sa 0 x-axis, right? Okay, ang x nimo is na-locate ang imuhang Q1 is at ayang coordinate 0.3, right, meter. Tapos ang Q2 is at 0, negative 0.3 meter. Now, ang charge Q as na-locate is at, so ang charge Q is na siya sa 0.4, x niya, 0.4 and 0 y. Okay? So 0.4 meter, 0. Okay? So the same gihapon ang idea ani if you want to calculate the total force that is felt by charge Q because of the presence of charge Q1 and charge Q2. So we have F, okay. I have FQ, F1Q plus F2Q. Okay, so kana. Then first we'll consider F1Q. Okay, so sa ating formula, ano naman gihapon? K absolute Q1 Q over R squared. So that would be 9.0 times 10 to the 9 Newton. And then the charge Q1, we recall charge Q1 is 2 microcoulomb. So that's 2.0 times 10 to the negative 6 coulomb. And then charge Q is just 4.0 times 10 to the negative 6 coulomb over R square is it's already in meters, so that's Q1 ang R between Q1 and Q is just 0.5. So we have 0.5 meter square. So if we calculate using calculator, so we have 0.29 Newton. Okay. But take note, punay ko an A, no ha? Okay. Now, the unsay pa feel nga force ani gani, we have Q1 and Q. So both are positive. So therefore, ang ma-feel nga force sa Q1 is repulsion. So ang arrow is dito straight line, but diagonal gihapon. Right? This would be F. Uh, this would be F1Q. Okay? But since diagonal man na siya, so ang ihang force is na a component. We have the X and the Y component. So the X and the Y, oh, baliktad, sorry. We are actually fine. Atong ipangita is naraday din. Sorry about that. Ang charge, mo na ni siya. Ang ma-feel nga force sa Q because of the presence of Q1. So kani siya nga direction kani. So naa siya component. We have the X and the Y component. Okay? And it makes an angle of alpha. Okay? So naa siya alpha diha. Okay? So we have F1 on Q X and we have F1 on Q Y component. So we can actually write it as this one. F1Q, the X component. Then I put the F1Q, the Y component. Okay. Let me try to solve the X and the Y component. So if you review sa inyo trigonometry, so this angle here is alpha. So this is alpha. Can see the cursor sa ang mouse. So this one is actually given by, you can ask me later na lang if na you can review sa inyong trigonometry. But that's actually katong Sokatowa bitaw. Sokatowa. Sa tong Sokatowa gani. You have sine alpha is equal to Sokatowa. Okay. We have opposite over hypotenuse. Then we have opposite over, oh, this is not opposite. This is now adjacent. Hypotenuse. And then tangent opposite over adjacent. I hope tutudo na siya sa inyo ang high school. So Sokatowa. So you have SOH. So you have Towa. So you have sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite hypotenuse. Right? So if you look at it, balik na din eh. So this is the triangle. Yeah. So muna siya ang triangle. Right? Muna siya ang triangle. So this is the angle alpha. So the opposite, adjacent, and hypotenuse. So therefore, kaning side, kaning force along the x component. So that's actually you have cosine alpha F1Q. Okay, and for the y component, that's sine alpha F1Q. Okay. Okay. So how do we find for the cosine alpha? So we have cosine alpha and we have the sine alpha. Okay, so you have cosine alpha, that's somehow this electric field is an innate property sa imong charge. Okay, so whether naa kay charge, there is actually a electric field present. So when another object, let's say a test charge, enter this electric field, so an electric forces acts on it because they interact. So if you have positive na mo positive, so maka-feel sila og the presence sa electric field sa matag usa. So if they are both positive, so they will repel, they will feel a repulsive force between them. But if it's opposite charge, then they will feel an attractive force, attraction. So the electric field is defined as the electric force on the test charge per unit charge. Okay, so it's given by this formula. So this is the electric field. So it's like that's why it's called a force, because electric field is given by this formula F over Q naught. Okay. So mo siya ingon ani man sa atong formula sa ato ang kana siya is gikan na siya actually diri sa katong Coulomb's law gihapon. So we have K Q say Q prime over R square, or it's just okay. Just say Q naught. Okay. So the electric field is just like this. So you have Q, so you have Q naught. Akong gi-separate lang, you have K Q over R square. Diba? The same naman na sila. So it's like this. So akong i-Q naught na siya. This whole thing, I will call that as an electric field. Right? So, nananin ko F equals Q naught E. So therefore, electric field E is just F over Q naught. So ito So that's the definition of electric field. So it's like a test charge Q naught, maka-feel siya og electric force because this electric field or electric force is due to the other charge, right? So electric field is produced by some charge or charge distribution if di lang kay point charge mo i-consider. If it's a charge distribution, so say a metal ball, continuous na siya distribution sa charge, daghan kay siya Q. So electric field is produced by some charge that is separate from the test charge. The charge itself makaproduce og electric field. So the existence of an electric field is a property of the source charge. And the presence of the test charge is not necessary for the field to exist. Okay? The test charge will just actually serve as a detector of the field. Uy, maka-feel nga, maka-detect ka o maka-prove ka nga, there must be an electric field present because ni-react ang imong test charge. So the direction of the electric field is that on the force on the positive charge given by this figure. So if you have a source charge capital Q and you have a test charge Q sub naught, so maka-feel siya og repulsive force, so the direction is to the right. Okay, ang iyang force. So we can also say that an electric field exists at a point if a test charge at that point experiences an electric force. So as what I've said kanina, mo siya ang formula sa imong force, right? So if Q is positive, the force and the field are in the same direction. But if Q is negative, the force and the field are opposite in direction. Okay. So always remember nga ang electric field is a vector form po na siya because force is a vector quantity. So magmatter ang imong direction aside sa quantity. Okay. So as you can see here, in the figure, so the force is repulsion, repulsive siya, padung dito. Okay, both are say positive na siya because dinana dito ang iyang direction sa force. But if negative, if positive ni siya tapos negative ang imong source charge Q, so the direction actually is attractive. So that's a visualization lang. It show ba nga asa dapit ang direction if you have opposite charge and same charge interacting. So we'll not discuss this anymore kay medyo advanced naman siya and it requires knowledge on calculus. But the general formula for electric field is actually kana siya padulong na siya og ma-integral, okay? R squared d tau, okay, is volume. Because in reality, di makakakita og point charge actually. They are point charges are found to be in nature dili point but a collection of charges. So nagsugod lang ta og point kay mas simple man siya, right? Mas simple siya. So in reality, kumpul-kumpul na siya. Say on a metal ball, on a rod, on a sheet of paper or sheet of metal na naay charge diha. So that's actually given by this formula. Ani. So, but we'll not discuss that anymore. So, kana. So, let's move directly to this one. So, people have come to realize na para mas madali masabtan ang concept on electricity, electric field, and electric forces. So, they have to come up with an idea nga how to represent man electric field. So, that's when they had to represent it using electric field lines. Okay. So field lines gives us a means of representing the electric field pictorially. And the electric field vector is tangent to the electric field line at each point. So we'll discuss that later. And the number of lines per unit that passes through an area is proportional to the electric field strength. So kung unsa kadaghan ang electric field line sa kanang region, that will determine if unsa ka kusog ang electric field. Okay. So like for this one, let's say na ay source dinhi. Say it's charge Q, diha ang source. So the electric field is given by this. So this is the general idea of electric field lines. This is non-uniform. Why non-uniform? Because mag-vary ang imong electric field strength based sa location. For example, take a look at area A and area B. So if abutang ko og piece of plywood, say that's area A, and I will count the number of electric fields lines there, that's actually greater compared to the number of electric field lines that I can count in area B. So mas maka-conclude ko nga mas pusog ang electric field sa area A compared sa area B because of the number of electric field lines that it passes through on that certain area. So which is makes sense pod kay as you go nearer sa source, magbutang na pud ko dinhi og magbutang na pud ko dinha, right? So mas kusog dinhi because mas daghan man ang counting dinhi sa number of field line. As you go further away from the source, it gets weaker. So magka-weak ang imong electric field strength. That would mean magkagamay ang number of electric field lines that passes through a certain area. Mura na po na og, let's say, the sun. The sun is very far away from the earth. So, but if you move closer sa source, mas maka-feel ka nga init, right? Because mas mas daghan ang iyang electric field, iyang lines, iyang number of photons, or number of energy nga ni-pass through for that particular area. But the farther you are away from the sun, mas hinay ang iyang strength, right? Like, mas magka-cold dito sa layo compared sa doon. Of course, mas magkalayo, mas magka-cold. So the idea of the field lines for positive, it's visually outward, as you can see it here. And for the negative, it's inward. So, natay rules sa pag-draw sa electric field line. The lines must begin on positive. Okay, di man siya visually outward man siya. And it will terminate on negative because ang negative is will accept pasulod siya. Okay? So in case of one type, say duha ka book ang imuhang duha ka charge, you have the positive and the negative. So some lines will begin and end padulong sa negative, but the other will just dito siya padulong sa infinity. Okay? And another thing is no two field lines can cross. So walay crossing of each other, that's the rule. Hindi siya pwede mag-cross. And remember that field lines are not material objects. So they're just a representation and to qualitatively describe the electric field. No one has ever seen an electric field line. We just know nga naa na siya diha because of how a charged particle react or interact. It's like magnetic field. How do we know nga na magnetic field? We can't even see it. Yeah, we cannot see it, but we can actually feel its evidence. So we can see an evidence nga that would lead us to the conclusion that there exists a magnetic field. Okay. So take a look at this. We have the field line patterns for positive and negative. So it begins, ang field line mo begin siya sa positive and then ends at the negative. And some other field lines, di siya mo connected to, but will just go to infinity. So if we have two positive charges, so muna siya ang ihang, that's why mo repel siya because of these field line patterns. So lahi mo na imong field line patterns if one charge is twice the strength of the other. So we have negative Q. So mas daghan ang field lines nimo sa 2Q compared sa field lines sa negative Q lang. And we also have charged particles na mag-move in the presence of an electric field. So maka-experience po siya ng electric force. So when a charged particle is placed in an electric field, maka-feel na siya og force. Say, if na ko electric field, and then I will put a negative, say ang electric field is padulong dinhi. So this is the electric field. If I put a negative charge, where do you think it will go? Unsa kahay motion sa imong negative charge? Okay? So you can think and pause this video for a couple of seconds and you come back and then you answer. Okay? So the answer is it will always move opposite to the electric field. Why? Because the direction of the electric field is actually this is the electric field of a positive. Okay, ana man na siya pa visually outward. Okay. So whenever there is an electric field is it always points from higher potential to lower potential. So if you have the direction of the electric field is this direction, so ang kaning electron or negative charge will always move opposite to that direction. So paana na siya. Kaya maka-feel man siya dito. Dito man ang force niya nga ma-feel because dito siya padulong sa lower niya nga energy configuration. And since maka-feel man siya og force, so maka-move siya, so it has an acceleration, it moves. It's given by this second law of Newton. So second law of Newton, just F equals ma, where F is just equal to QE. So if I have say a charge here, correct? Tapos ni-move siya in the presence of the electric field. So take a look at the electric field. Always na siya from positive to negative. So ang electric field. So this is a negatively charged. If mo-move na siya din ha, so maka-feel na siya og force padulong sa ubos. Kay ang negative charge maka-move man na siya opposite sa direction sa electric field, right? So it's like ang negative mo attracted sa positive. So that's why mo siya mo parabolic. Na siya velocity v initially. Pagsulod niya sa electric field, maka-feel siya nga na electric field. So mo-move siya downward. That's why naiyang motion. Okay, that's how the charge moves in the presence of an electric field. So if, let's say, isa na negative na siya, let's say positive na siya, so opposite po ang iyang movement pa curve upward po siya. Okay? Okay, that would be all for this chapter about charge, electric field, electric force, and then motion of an electric field in a motion of charge in the presence of an electric field. So that summarizes our lecture for this whole chapter on electric field and electric forces. So if you have any questions, you can directly message me sa Facebook, sa itong group chat. Pwede mo mag-message dito. You can email me, or you can even set an appointment where I can call you, or we have a video call, or sa Google Meet. Okay? That would be all, class, and thank you, and stay safe always. God bless.